Hi everyone, we are looking at functional graphs today. This is all based on Text and Test 5 Chapter 8 and this video will be based on these 8 pages here. I'm going to start off by just introducing these two things, which are both called relations or rules, or you'll sometimes see ordered pairs. You see a few different names. And what's important in this chapter is that I suppose we just develop a comfort, or in this section, a comfort with what we mean when we use very specific words in relations to these type of rules. Okay, so both of these rules generate what are called ordered pairs. So say 1 and 4 makes a 5, or 2 and 3, or 3 and 2, or 4 and 1, or 5 and 0. Those are all ordered pairs, okay? And there's an infinite set of points that I could put in there if I wanted to, but I'm just going to leave it at those 5. Over here, 3 could go with 4 because 3 squared plus 4 squared is the same as 5 squared. Okay, that's 9 and 16 makes 25. You could have 3 could also go with -4. Okay, so that's important in that this input of 3 can give 2 possible outputs of 4 or -4. Similarly, -3 can go with 4, or -3 can go with -4. Okay, -3 squared plus -4 squared, that's still plus 9 plus 16 makes plus 25. So all of these points are obey this rule as well. Okay, so one of these is a function and the other is not. So we'll be discussing why one is a function in just a second. So I've just sketched out what's called a mapping diagram. You'll see these in the book quite a lot. They're really only used as a teaching tool. You won't use them very often in practice, I suppose. But these are my input values, 3 and -3. My output values, 4 and -4. Okay, my input values are called the domain. Up to now, we've really called them the x values, and that still gets used quite a lot. The domain or the x values gets used to describe the domain quite a lot. Your output values here are called your range. Okay, so those are the first two words that I think it's really important that you understand what a domain and what a range is. Range there are your y values, is what you might have called them for junior set. Okay, and this first mapping diagram doesn't represent a function for this reason. 3 can generate a 4 or a -4. Okay, so because this input value corresponds to 2 output values, that is not a function. Whereas over here, 1 can only correspond to 4. Okay, there's no other number that I can put into this rule. 1 plus something gives 5. If I put in a 1, I need to put out, my output value needs to be a 4, or my corresponding y value. Excuse me. Similarly, 2 can only correspond to 3, 3 only corresponds to 2, 4 as an input only corresponds to 1, 5 corresponds to 0. Okay, and it's not a problem that this number 3, for example, is on the domain corresponding to 2, and it's also on the range. Okay, don't worry about repeated patterns like that. That'll happen quite a lot. Okay, so here's our definition of a function. Do take this down because this is kind of an important thing to understand. That a function is when each element on the domain, that might be called the x values, each one of the x values corresponds to one and only one element on the range, which might be called the y values. Okay, but it's that one-to-one correspondence that is important. And if we were to plot these out, that first shape, x squared plus y squared equals 5, that's a circle you might remember when we studied coordinate geometry. The circle would center at 0, 0. So 1, 2, 3 out, and 1, 2, 3, 4 up, 4 out, and 3 up. Okay, all of these points, 3s and 4s, are all going to 4 and 3. They're all going to fit onto this circle. So I might just actually pause and complete that without you watching the whole thing. Okay, and just I suppose to point out as well that 5, 0 will fit in there. 5 squared plus 0 squared makes 5 squared. -5, 0 fits in 2. -5 squared is 25, plus 25. Plus 0 gives 5 squared is 25 as well. So you get all these points here. And you form them up to get a circle if you plot this out. From our point of view, is this a function? No, because it fails something called a vertical line test. If I draw a vertical line through any point here, it crosses the function twice. Okay, which means this input 2 corresponds to two different outputs, and therefore a circle does not represent a function, not as it is drawn at the moment. Whereas my rule x plus y equals 5 generates the points 4, 1, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0. Okay, and this point 0, 5 is there as well. That's a straight line, which we would have known from junior cert. But again, if you draw any vertical line through it, it only crosses once. It crosses exactly once, we say. So that is a function. Okay, so that's the difference between a function and just a relation or a rule, is that a function has this rule that each element on the domain corresponds to one and only one element on the range. Okay, so if we go to page 235, question 2 here says investigate if the following relationships form a function, and if not, why. So the first one here, 0 corresponds to 0, 1 corresponds to 1, 2 corresponds to 4, 3 corresponds to 9, 4 corresponds to 16. So our input values, or our domain, are 0, 1, 2, 3, and 4, and each of them have just one unique output value that corresponds to them. So that first one, that's a function, no problem. Second one, our input values are -2, -1, -2, 1, 2. Now look, -2 is repeated there, but in the first time it generates a 1 when you plug a -2 into our rule. Second time it generates a 5 when you plug a -2 into our rule. So -2 on the domain has two output values, or two values on the range that correspond to it. So this second relation or set of couples is not a function. The third one, -3 corresponds to 4, 0 corresponds to 11, 2 corresponds to 9, 4 corresponds to 11. That's fine. Okay, no problems there. Question 3 gives it as a mapping diagram. Okay, and our first mapping diagram, each element on our domain, that's our set of inputs on the left, corresponds to one unique element in our set of outputs there in the range on the right. Whereas over here, A corresponds to 2, it generates two different outputs. Okay, so that is not a function. Okay, if it generates two different outputs, that's not a function. Just to point out, it is not a problem for A and B to both give the same output value. That still makes it a function. Okay, the problem here is that A corresponds to these two outputs, or C corresponds to these two outputs. That's why it's not a function. Okay, so part 3, 3 corresponds to 9, no problems. 5 corresponds to 9, still no problems. You're allowed to have the same output value be generated. But 9 here corresponds to 14 and to 20. So that's our problem. No, part 3, that is not a function. And part 4, P corresponds to A, no problem. Q corresponds to A, no problem. R corresponds to A, and S corresponds to C. So each element on our domain, these 4 elements, corresponds to only one element on the range, these 4 elements here. So that one, yes, that is a function. Okay, if I can bring you back to page 231, just to examine quickly this notation. This rule, x squared plus 6, is represented 3 different ways here. Those are 3 equivalent ways of saying the same thing. All of them say this is a function where if you take an input number, x, what you do with it is you square it and then you add 6. And that gets your output. So your output equals your input number here squared plus 6. Okay, but all 3 of these are the same. These 3 notations all mean your output value is. Another thing I'll just draw your attention to, if you're not familiar with these 4 terms, if they look unusual to you, well, sit down and learn this off by heart, because this is important. Okay, these will come up in the notation a lot. This is the natural numbers, you learned that in first year. The set of positive whole numbers. The integers is the set of whole numbers. Rational numbers, which are numbers that can be written as a fraction of whole numbers. So where the numbers top and bottom of the fraction are both integers, then that's a rational number. And R means the real numbers. Okay, and for junior cert, we said the real numbers are all of the numbers in the number line. Now that we've studied complex numbers, we know that some numbers are imaginary and some numbers are complex. But when we're talking about the real numbers, we say, well, the real numbers minus the rational numbers leaves this type of number, which is an irrational number. Pi, root 2, e, all examples of irrational numbers. Okay, and just to introduce one other term here, this word codomain is the set of allowable outputs, I suppose, is what you might call it. So here, the rule here is square x squared. So your inputs are natural numbers. So your input numbers are only whole numbers, 1, 2, 3, 4. So your outputs, 1, 4, 9, 16, they form the range, okay? But they sit within a larger group called a codomain. For example, 3, okay? 3 is on the codomain, but it's not on the range because there's no natural number I can plug in here that when I square it gives 3 as an answer. So even though 3 is, it's an allowable output, okay? We're not restricting this in any way and saying, no, you can't put numbers like 3 in it. You'll never generate a 3 with this function. So the numbers you actually generate are the range, whereas the numbers that you could potentially generate are the codomain. So here, our codomain and our domain are the same. They're both the natural numbers, where our range is just the square numbers, 1, 4, 9, 16. So question 16 on page 238 asks you to state the domain and range for the relations represented by each of these following graphs. So your domain, your set of allowable inputs in this first one is any number. You can plug any number. This is just a quadratic. So x is an element of the real numbers. That's what you might write there. Whereas your range, your outputs, well, no number less than -2 is possible. So your output has to be defined as values that are greater than -2. But again, real numbers, any real number. So here's how you'll write that. You'll say x is an element of the real numbers. And then you might say something like f of x, or the output needs to be greater than or equal to -2, and is an element of the real numbers. Or you might see y needs to be greater than -2 and is an element of the real numbers. Or you might just see it defined as y equals the set of numbers between -2 and infinity. Again, you'd normally say what type of number that represents, and you wouldn't say that it's an integer, for example. In this case, you don't want that to be inferred. It can be any real number there. Okay, so this is your domain. This is your range expressed in a couple of different ways, but all of them say between -2 and infinity. Okay, if we look at the second question from 16 there, your allowable inputs are restricted. Now, you can't really plug a 3 into this function. It doesn't correspond to any outputs. So your domain here would be between minus infinity and 2, whereas your range would be between any real number would be allowable on the range. So sorry, just to show you what that's going to look like. This is your domain. Okay, and you might say x is an element of that set from -infinity to 2, and that's your range. Just to point out that that second example is not a function. You can still talk about its domain and its range, but it is not a function because it fails the vertical line test. If you plug a 1 in, there's 2 possible output values you can get. Okay, you can get whatever that is, -0.2, or you could also potentially get this value, 2.2, or whatever that might be. So because there's 2 possible outputs for 1 possible input, it fails that vertical line test. That is not a function. Here are allowable inputs. So these dots mean that's the end of the function. So your allowable inputs are between -2 and 3. Your allowable outputs are between 0 and 9. Okay, 0 is the lowest number you can get, 9 is the highest. So the domain here is between -2 and 3. The range is between 0 and 9. The codomain is, I suppose, potentially all of the all of the real numbers. So again, this one's restricted. Domain is between -3 and 1. Range is between -6 and 2. This is not a function because it fails our vertical line test, but we can still say that the allowable inputs, that's a -4 over there. The radius of the circle is 2. So -4 to 0 are our domain, and 0 to 4 is our range, our allowable outputs. Here, we've got an asymptote up the top here, so we're not allowed to have an output value greater than 4. Any input value you like, you can plug any number into this function, but it will never get bigger than 4. So you would state for this one, your domain is the real numbers, whereas your range is numbers between -infinity and 4. And just actually to show you what that one looks like written down, because you're not allowed to have 4 as one of your outputs. For that last one, I think it's 6, is it? You'll say, yeah, I can plug in any number I like. My inputs are the real numbers. My Y might be the set of numbers between, so -infinity is not a value you can have, and -4 is, sorry, +4 is also not a value you can have. So we put a round bracket to say we cannot take 4 as an answer. Whereas up here, we were allowed to take -2 as an output value. So we put a square bracket around that. I probably shouldn't have had a round bracket. Infinity always takes a round bracket because it's not a real number. It's an idea. That can also be written as y is between, less than or equal to 4 and -infinity, where y is an element of the real numbers. There's multiple ways that these can kind of be represented, all of which mean the same thing. I'm just going to finish up talking about restricting a domain, where you might say, well, here's my rule, y equals the square root of x. That doesn't work if x is a negative number. Okay, if we're assuming that y has to be a real number, then x would have to be positive. It would have to be greater than 0 and a real number. Okay, so that's called a restriction on your domain. We'll see more about restriction domains later on, but for the moment, just you'll often see something like that put in, and it's called a restriction on the domain. Okay, so I'm going to leave it there. I'm going to ask you to do questions 1 to 5 from that exercise, and just put down, I've sent them in the recordings, all the answers, but the answers to question 16 and 17 there, if you put them into your copy as well. All right, thanks guys.